The last step in starting up the FPG piston cylinder is to quantify the stability of the system by performing a 60-second drift test. The 60-second drift test is to be performed in gauge mode after reinstalling the piston cylinder, and the objective is to quantify and document piston cylinder stability. From the Run menu, we select Run with Point Log. This enables the data acquisition for the system and allows us to plot the output of the balance. Close out the data grid and click on our plot window, Logged Plot Data. And we're going to select a custom plot. And we're looking here for N versus points. If this is not already created on your machine, you must first go down and click on Create New Custom Plot, put in the appropriate title, and for the x-axis, choose point and N for the y-axis data, and then save. So from our plot selection, we choose N versus point, and we click on Plot Selection. We go to the Start Auto Point Taking button, which looks like a stopwatch. Click that once, and we enter the time delay for points. So we put a 1. This means that once a second, the FPG tools will capture the output of the FPG balance and plot the output. So we type in 1 and hit OK. And without touching the bench or inducing any other vibrations, we're plotting the output of the balance. We're sampling the FPG output for a period of 60 seconds. What we are looking for is a time base of 10 seconds or longer where the output does not change. If this is not achievable, then we will look at the entire 60-second period and we'll look for a net change of 0.4 counts peak to peak. Or if you have the standard resolution FPG, 4 counts peak to peak. While the FPG is plotting the output, it is also creating a data file, and this data is saved to your local hard drive. The benefit of having a saved data file is that it provides a proof positive that you have a stable and clean FPG. And if this needs to be troubleshot in the future, we now have a record which we can reference to say, yes, at a certain point in time the system was clean, or yes, it is still clean. So at the end of 60 seconds, we go up to the stopwatch and we press it again to stop the point logging. And now becomes the time where we analyze the data. On our screen, we're first and foremost looking for a section where there's no change for 10 seconds or more. This section right here begins at about 19 seconds and continues unchanged outward to about 37, maybe 38 seconds in time. Our criteria is 10 seconds or more, zero change, and we definitely have that met here. So because of this flat line section, we have positive proof that the FPG is clean and stable. These other fluctuations before and after, these are inconsequential relative to this section of flat line. To exit the drift test, we go back up to the Run menu, select Run Monitor, and now we can close out our plot.